Okay, we have seen that there are 4 different types of data. We're mostly going to be interested in data of the ratio type, numerical data that actually is measuring some kind of quantity. So there are 2 kinds. Of numerical, or really we can think of that probably as ratio, perhaps sometimes it'll be interval data, but there are 2 kinds of data that come in number form that we're interested in. One, we call it discrete data. And these are where the data values are obtained by counting. Each data value is obtained by counting. So, for example, we maybe survey some families, and the data values are the number of kids in each family. Okay, so possible values there. Okay, well the obtained by counting. So I look at the first family I survey and they have maybe no kids. I look at the next one, maybe they have 1, etc. So I'm counting the kids, right? All the way up to, I don't know, the Duggins have 20 or whatever they have. I don't know. So the important thing to understand here is I'm getting each value by actually counting. So if you notice, the word discrete sort of suggests that the numbers are in separate chunks. They're separated from each other. And that's pretty obvious here. Let's contrast that with the other kind of data, continuous. And this is the where the data values are obtained by measurement. And, well, let me just go ahead and give you an example here before I say more. Example. Well, what do I have down? Well, maybe heights of people. All right, so we take a bunch of people and we measure their height. Maybe the shortest person we measure is 54 inches, and the tallest, that's 4'6", and suppose the tallest one is 6'6", that'd be 78 inches. All right, but what we really have, don't we, is a whole interval of possibilities here. If we keep measuring more and more and more people, we would fill in more and more of the values in between here, and it's not like there's any one height value and then there will always be a next one, because if there's a next one, there could be one in between those two, et cetera, et cetera. So what we really see is for a continuous random variable, values generally lie in an interval. And it could be any value in that interval. Whereas over here, I don't have an interval between 2 and 3, right? There's only 2, and the next one is 3. I don't have, I can't have children in between, number of children in between 2 and 3, for example. But up here, I can have pretty much any number in between whatever the lowest and whatever the highest value is. Okay, let's see. So let me put 2 problems here, if I can get them in, and have you pause and think about these. So what if I was asking for the number of fries in a medium pack of fries, I don't care, at McDonald's. Okay, is that discrete or continuous? And then number 2, maybe I'm asking for the number of ounces of grease to fry the pack. Okay, so pause me and think about it and write down what you think this kind of data would be. Would this be an example of a discrete or continuous? And do the same for number 2. So please pause me and then we'll see if you get it right. Okay. Number of fries in a medium pack, of course, I'm just going to dump them out and count them, right? And we'll count little ones, big ones, half ones. We'll count them each as a fry, so I can easily just count. So this is obviously discrete. Number of ounces of grease to fry. I hope I can fit this in. Yeah, it looks like I can. Well, of course, it could be anything from 0 ounces, highly unlikely, all the way up to, 10 ounces or more, right, to fry the grease. And it could be any value in that interval, right? So this would be a continuous type of data, and I'm going to abbreviate continuous as CTS. And we will stop there.